All right, so here's some help on this review sheet that covers basically all of Chapter 6 to get you ready for this next test. So let's get started. First two problems have you writing exponential functions, and exponential functions are generally in this form. B is either a growth factor or a decay factor, depending on whether the item is increasing in value or decreasing. And so number one is describing depreciation of a car, which means the value of the car is going down every year by 8%. So to write this exponential function, we have A, which represents the initial value of the car. It started off being brand new. It was valued at $50,000. B, in this case, is going to be a decay factor. So the way to get a decay factor is you always start with the number 1 and then subtract from that whatever the rate of decay is. So 8% as a decimal is 0.08. So if you went to your calculator and you did 1 minus 0.08, that would tell you that B, this number right here directly below X, is 0.92. Okay, so what I've done so far is this first sentence. This function models this particular situation. Now I'm going to use this function to do the second sentence. The value of the car at this rate of depreciation after 8 years or 5 years, I just raise or I replace X with 5, raise 0.92 to the 5th power. And now you can just grab your calculator and put all this in. So 50,000 times 0.92 raised to the 5th. And it says to the nearest dollar, so you should not have any decimals in this case. So $32,954. So it was $50,000 new, but after depreciation for 5 years, it has decreased down to that value. Number 2 represents exponential growth. So same basic equation, function, started off at 10,000. That's the initial value. So for a growth factor, notice I still start with the number 1, but I'm going to add the rate of growth as a decimal. So 5.5% in decimal form is 0.055. So when I add these two together, that's what B is. All right, so there is my function that models this situation. And now using this function to come up with the value of the property after 5 years. So again, go to your calculator. 10,000 times 1.055 raised to the 5th power. It has grown to 13,000, and it's 13,069.6, and so to the nearest dollar, we would say $13,070. All right, that is numbers 1 and 2. 3 and 4, I'm going to see if you remember the common base. Rewrite this equation so that each side of the equation, the numbers are in the same base. Just a little note here for you. So I can leave 4 just like it is and represent 16 as the same base, 4 being raised to the 2nd power. And I'm just bringing down the x. So when you have the same base on both sides of the equation, you can just let one exponent, the left exponent, equal the right one. And now we just solve for x. So I'm going to subtract 2x from both sides. And then I'll add 1 to both sides. And there's my answer for number 3. All right, number 4, the common base that I'm going to use to represent 1/9 and 243 is 3. So 3 to the negative 2 is the same thing as 1/9. And 3 to the 5th is 243. So once you get to this point where you have the same base on both sides, then you just let the left exponent equal the right. Just be careful that you distribute the 5 to both of those. Okay, subtract 5, divide by 10, and your answer in this case is negative 7/10. All right. Number 5 is another exponential function problem. So our end result is going to be this, but the way we're given the information, we'll approach it just a little bit differently. We don't really know right offhand what the rate of growth is. We know it's growing because we started with 6,000 and it eventually became 28,000. But what we don't know is what percentage growth that is. So we're going to solve for B in this case. All right, so 28,000, what the number became after 2 hours, that will replace Y. A is the initial value, how many we had at the beginning. I said earlier we're going to solve for B, and X represents how long it took, what time interval did it take for 6,000 to become 28,000, and so B is 2. So solving for B, I would first divide by 6,000. 28,000 divided by 6,000. And we'll just run this out to 4 decimal places for our final answer for B. So right now, I'm not going to do any rounding. I'm going to wait, and I'll do that at the end. But in your calculator, you should be showing 4.6666, eventually, about 9 decimal places, depending on your calculator. So what we're going to do now to solve for B, so just leaving that decimal in your calculator, the 4.66 number, I'm just going to raise that. So just show you what I'm doing in my calculator. I'm going to raise that decimal to the 1/2 power. And doing this is the same thing as doing a square root. You just have to, whenever you raise a fraction as an exponent, you've got to put parentheses around the fraction. So 1 divided by 2. So that tells me that B is, and I'll just round this to 4 decimal places, 2.1602 is B. So now I'm ready to go ahead and finish my answer for part A. I haven't written a function yet. Okay, so some of you've seen this problem in the past and you just stopped at whatever B is, but the question says to write an exponential function. So the answer to part A is Y is going to become a beginning total of 6,000 when growing at this rate over a certain amount of time will become whatever the ending number is. Okay, so that's the answer for letter A. Letter B, now we're actually going to use this formula and we're going to replace X with 4 to get our answer. So you can just plug this into your calculator. So 6,000, so I'm doing this in my calculator, 6,000 times 2.1602, and we're going to raise that to the 4th power. And since these are living things, so we don't want to have any decimals, so that's 130,000 655 bacteria after 4 hours with that rate of growth. All right, number 6 is a continuously compounded interest form or problem, and we have a special formula that we learned the other day. This was your homework problem number 51 in lesson 6-8. So if you want to go back and review that problem, you can. But here's the formula that you're going to use whenever the interest is compounded continuously. So letter A, how much are you going to have in the account after 7 years? A is how much we will have in the account. We started with 8,000. And we're going to raise E to the rate of 4.5% as a decimal, 0.045. And we're going to multiply times T, which is the number of years. Okay, so back to your calculator, and you're going to do 8,000. Then you're going to do the E to the X, second ln. And in the parentheses for the exponent, 0.045 times 7, close parentheses. And for these compound interest problems, let's just go ahead and round to the nearest penny. So 10,962 and 7 cents. All right, letter B, how long would it take to double your money? So if we invested 8,000 and it doubled, then it would become obviously 16,000. Same interest rate, but we don't know how long that would take. So in this case, we're going to be solving for T. So I'm going to get E by itself so I can change it into a natural log equation. All right, so now that E is isolated as a natural log, this would be natural log 2 is equal to the exponent. Logarithm equations, in logarithm equations, the log should always equal the exponent. So now go back to your calculator, natural log 2. And that's going to be divided by 0.045. So you're just basically algebraically, you're doing this. And it's going to be about, we'll round to the nearest tenth, about 15.4 years. All right, letter C, if we want to double our money in 11 years, what would the rate be? So basically B and C are very similar. We're just solving for two different variables, but the process is very much the same. Okay, now turn this into a natural log, so it's going to be the same. So this time we're going to do natural log 2 and then divide by 11. And percent form rounded to the nearest tenth, moving the decimal 2 places to the right. It's about 6.3%. And then finally, if we want to open an account, pays 5 1/4 interest compounded continuously, we have 15 in the account, 15,000 in the account. How much are we going to need to deposit? Well, that's what P represents in this formula. All right, so the rate as a decimal, 0.0525, and it's going to take 9 years. So really, you're able to you're going to be dividing both sides of this equation by e to that power. And so this is, the left side is really what we're doing in our calculator. All right, so let's go 15,000 divided by, and then do e, second ln, e to this power. So in the parentheses, you're going to put 0.0525 times 9, close parentheses. And to the nearest penny, that would be 9,351 and 63 cents. Okay, to find the sum of a geometric series, this is our formula, just a little review. N is the number of terms, so this is going to be 9 terms. A sub 1 refers to the first term. R refers to the number that would be multiplied to get from one term to the next. So it looks like we're multiplying by -3. 4 times -3 is -12. -12 times -3 is +36. So that makes R -3. And since we have 9 terms, we'll raise -3 to the 9th power. All right, and so you're ready to turn this over, let your calculator do the work. So 4 parentheses, 1 minus, and I'm going to put -3 in its own set of parentheses, just like I have it written. Raise -3 to the 9th power. All right, I'm closing the parentheses. And I'm going to do divided by 4. But if you wanted to do it just like I have it written here, then you would need parentheses around 1 minus -3. But entering it in as just divided by 4, you don't need parentheses, so the answer is 19,684. Number 8 is sigma notation. We're going to use this same formula. The number of terms will be 7 minus 2 plus 1. So it looks like there's going to be 6 terms for number 8. To get the first term, just take this number that they say is equal to k and plug it in for k. So when I do that, I'll just show you off to the right what that looks like. -1 times 2/3 raised to the first. So if k is 2, 2 minus 1 is 1. So this is just going to be -1 times 2/3. So that's my first term, -2/3. R is this. It's always in sigma notation. It's whatever the base for the exponent is. So in this case, it's going to be 2/3. It's going to be raised to the 6th power. All right, so again, if you do all of this 1 minus 2/3 in your calculator, then you need to pair up, you need parentheses just like I have it written on this paper. So let's go to our calculator and make sure you're able to get this answer. So I would just use parentheses exactly like you see the way I've written it down. Left parentheses, -2 divided by 3, close parentheses, left 1 minus parentheses 2 divided by 3, close parentheses, raised to the 6th power, close parentheses, divided by left parentheses 1 minus, and then I'm going to put 2/3, 2 divided by 3 in parentheses, and then another final parentheses. So you're going to have inside set surrounded by an outside set of parentheses. So we end up with our sum is -1.82, and we'll just go to 4 decimal places. All right, now we're moving on to log equations. So the deal about log equations is, first of all, these two logs, multiple logs, always have to be merged into one. And so that's why we learned the quotient property. This is log base 5 of x over 2. And now I get to apply the log property of equality. Since I have the same log on either side of the equation, they just cancel. And I just solve the rest. And so here I'm going to multiply by 2 on both sides. And I get x is 30. Number 10, same approach. I've got 2 logs this time being added. So 2 logs being added become 1 log using multiplication. So I'm going to be multiplying n times n minus 4. All right, so I've taken care of merging the 2 logs together. Now I get to apply that same log property of equality since I have the same log on both sides. And I'm just going to solve this quadratic equation. To solve by factoring, I'll make it equal to 0. I'll look for the factors of -5 that add up to -4. I find the solution for each of the factors. Then I want to know if both numbers are okay. Not for -1. I can't let n be -1 because I can't do the log of a negative number. So my only good answer for number 10 is 5. Number 11, I've got the product property on the left side. So 1 log of the product of 8 times n minus 4. And then I've got the quotient property on the right side. So they're being subtracted. But I've still got the log property of equality. So I solve 8n minus 32 equals n plus 11 over 2. So just multiply by 2. That will get rid of that denominator. Do the same thing on the other side. 16n minus 64 is equal to n plus 11. Subtract n from both sides, add 64 to both sides, divide by 15 on both sides, and you get your answer. Number 12, this is a log equation, log on one side, so to solve this one, I'm going to turn this into exponential form. I notice there is no base showing, so it's understood to be 10. The exponent for 10 will be 5. And I let that equal the expression 2x plus 3. So you can go to your calculator. It's 10 to the 5th. Subtract 3. Divide by 2. And you get x is 49,998.5. All right, these are exponential equations, and so for exponential equations, we need to turn them into log. I'm going to do log on both sides. I'll do the power property on the left side, since there is no exponent on the right. And now I just have to undo multiplication with division of log 7, so those will cancel. And now just go to your calculator and key this in exactly like I have it here. So log 29 divided by log 7. And then to get my answer for m, I would subtract 1. So 1.73044 is what I currently have, but when you subtract 1, that's 0.73044, so it looks like it's going to be 0.7305. It says to round to the nearest 10,000. All right, next one, same process, log on both sides. This time I've got r on both sides of the equation, so we'll do the power property on both sides. And I'm going to have to distribute log 12 to both of these, r and -1. Because eventually I want to get the r logs together on one side so I can factor out r. So factoring out r, and now I can get r by itself with division by log 12 minus log 7 on both sides. So once again, be careful about how you use your calculator. On the left side, those are just going to cancel. So r is going to be this result in my calculator. So log 12 divided by log 12 minus log 7. So we should have parentheses around this entire denominator. And then around these two numbers separately. So total of 3 sets of parentheses in the denominator. And we got our answer for R, 4.6102. Okay, 15 and 16 work the same. They're just inequalities, but the process is the same. I'm going to do log on both sides. So I can apply the power property on both sides. Since I have the variable on both sides, I'm going to have to distribute. So I can get the x logs together. So I can factor out x. And now I can solve for x by dividing by this on both sides. You just have to be careful with inequalities. We've talked about this. This number that I'm dividing by, if it's a negative, then that would cause me to have to switch the direction of this inequality. But it looks like it's going to be positive. Since 5 is bigger than 3, when I subtract 5 minus 3, that would be a positive number. So log 5 minus log 3 will also be positive. So let's go to our calculator. Negative 2 log 5 divided by, and then just like I have it written, parentheses around the entire denominator. And then around each number separately. So we're going to have x is less than or equal to negative 6.3013. And then number 16 is the same. It's just a little bit easier because the w is only on one side of the inequality. Still do log on both sides. Power property on the left side. And now to solve, we just do log 6 on both sides. So go to your calculator and key in log 23 divided by log 6. And just leave that whole decimal there and wait until you're done solving for w to do any rounding. So at this point, I've got 1.749952641 after doing this division, log 23 by log 6. So now I'm just going to add 5, enter, and then I'm going to divide by 2, enter, and I got W is greater than 3.3750 after rounding. All right, moving right along. Now we're going to get into some exponential and natural log equations. So just a little tip here, when you're solving these exponential equations like 17 or inequalities like 20, it's true in both cases, you want to isolate e to whatever the power of e is first. So in number 17, I'm going to add 11 to both sides, and then I'm going to divide by 4. And now I'm going to turn this into a natural log equation. Natural log 7 is equal to x, and I just have to let the calculator tell me what that is. Natural log 7, and still rounding to 4 decimal places, 1.9459. Okay, 18 is a natural log equation, so they need to be converted into exponential. But remember, the base of a natural logarithm is e. So when I change this to exponential form, it's e raised to the 5th power is 4x minus 1. And now go to your calculator. E to the 5th. And again, just leave that whole decimal there, 148.4131591. Add 1 to that, enter, and then divide that by 4, enter, and you'll get 37.3533. So as far as showing your work on problems like number 18, this is really all I need to see, and then you can do the rest in your calculator. 19 is a natural log inequality, so it needs to be changed into exponential inequality. The base of a natural log is e. The exponent for e is going to be 2. So just be careful when you turn this inequality into exponential. The inequality is pointing in 2's direction, so it still should be pointing in 2's direction when I'm done, or else you've changed the problem. So find e to the 2nd power, and then minus 1, and you get 6.3891 is less than x, or if you prefer, you can say x is greater than. Either way is fine. All right, so number 20, I need to isolate e to the x, so I'm going to subtract 2, and then I'm going to turn this into a natural log. All right, so natural log 7, since the inequality is pointing at x, it still should be pointing at x. And go to your calculator. And 1.9459 is greater than x, or again, you could turn it around if you like. Either one of these is fine. You don't have to have both. Okay, let's do this number 21, which is a review of our properties. So we're going to eventually put these 3 natural logs together as one. So first I've got to apply the power property. So moving the 2 so that it becomes the exponent for 6, natural log 36. Moving the 3 so that it becomes the exponent for 4. And then moving the 5 so that it becomes the exponent for 1/3. Take them two at a time. Two natural logs being added become one natural log of the product of 36 and 64. It's 2304. And two natural logs being subtracted become the quotient, one natural log of the quotient of. And we talked about this a few times this year. Complex fractions, really dividing by this fraction means to multiply by its reciprocal. So it's really 2304 times 243. And so the answer is going to be natural log 559,872. Okay, a little review of the number I with this block of problems. So I'm going to do some factoring. The square root of negative 18 would factor out as the square root of negative 1 times the perfect square root 9 times the not perfect square root 2. So simplifying these first two, the square root of 9 is 3, and by definition the square root of negative 1 is I. So I had two radicals that I could take care of, but the other one, the third one, couldn't do anything with. So my final answer for 22 is 3I root 2. 23, before I can multiply these together, I have to change them into real, can't multiply two radicals that are not real. So the square root of negative 4 is 2I, and the square root of negative 10 is I times the square root of 10. So now I multiply these two imaginary numbers together. 2I times I is 2I squared. And I squared, let me just write this. I is equal to the square root of negative 1, so I squared is equal to just negative 1. So saying 2 times I squared is really like saying 2 times negative 1. So my final answer here is negative 2 times the square root of 10. All right, number 24. I just have to simplify. It's pretty easy to simplify the square root of negative 25, and that's 5I. And just make sure that when you write complex numbers, this is a complex number is part real and part imaginary, but the real part always has to come first. So that's my answer for 24. 25, we said a minute ago that I squared is equal to negative 1, so this is really like saying this, and if you do this inside part first, it's I times negative 3, which is negative 3I. When you raise I to a power, every time you raise it to a multiple of 4 power, I'll just do some examples. This isn't exhaustive, but every one of these exponents that I'm writing is a multiple of 4. 4 goes into it evenly. So the interesting thing about every one of these, every time I do this, they all equal 1. Every time you raise I to a multiple of 4 power, it equals 1. So rewrite this using a multiple of 4 exponent times I with whatever needs to be made up. So these two, remember when you're multiplying, this is adding exponents. So when I multiply these together, it's like putting I to the 40 plus 2 power. Okay, so I to the 40th, we just said, is equal to 1. And we said earlier that I squared is equal to negative 1. So when you multiply these together, you get negative 1. All right, we're going to solve number 27 by factoring, and factoring in cases like this where the coefficient of x squared is greater than 1, we're going to use the box method. So I multiply those together, and I try to come up with the factors of negative 6x squared that add up to positive 5x, and that would be 6x times negative 1x. And then find the 4 GCFs out of this box. So 2x and negative 1 going across this horizontally, x and 3 going vertically. All right, so I've done the factoring, but so far I haven't done the solving. So don't forget, if you're solving by factoring, we haven't finished yet. So it's all we have to do is take each of the separate factors, these two factors, and make them each equal to 0 and solve. So x is 1/2, and then x is negative 3. Now it's solved. When you tell me what x is equal to, then you have finished solving. Okay, a little review of composite functions. So the way this is written, I'm going to take the g function, this g function, which is 3x minus 2, and it's going to become an input into the f function. All right, so it's going to look like this. Wherever I see x in this f function, I'm going to replace it with 3x minus 2. So replace that one. Now I'm going to replace this one. And now I'm just going to simplify. So if you don't feel comfortable doing this the other way that I showed you, you can use 3x minus 2 times itself and FOIL, the FOIL method. Okay, so remember to do powers before you do multiplication according to PEMDAS. Now I'm going to distribute the 2. I'm going to distribute the 4, bring down the minus 3, and now it's just combining like terms. So minus 24 plus 12 is minus 12x. And then I have 8 minus 8, which is 0, and then minus 3. So there's my answer for that composite function. All right, now we have a synthetic division review. So I'm dividing by x plus 3, so I put negative 3 in the house. And to the right, it's 2. Negative 3, negative 4, 15, didn't skip over any exponents. Bring down the 2 to get started. You never have a number in this little space right here. Bring down the 2 and then multiply. 2 times negative 3 is negative 6, and then you add. Negative 9 times negative 3 is positive 27, and add. 23 times negative 3 is negative 69, and you add. That should be 54. All right, and we divide it into third degree, so this should be second degree. So 2x squared minus 9x plus 23, and the remainder of negative 54 is going to go over x plus 3. Okay, and we got one more. So going all the way back to chapter 1 and algebra 1, using elimination, you could leave it like it is because I have a matching pair of y's here that I could eliminate with subtraction. Some of you would prefer to do this, and that's fine. You might prefer to multiply by -1 on the bottom, and then you would be adding. Doesn't matter to me, we'll get the same answer either way. If you just left it like it is and you subtracted, 6 minus 2 is 4x, the y's would cancel, and -46, this would be plus 26, because you're subtracting a negative, would be -20. So x is -5. So over here, I'll just show you to get the same thing. This would be 4x, and -46 plus 26 is -20. Okay, so now take your value for x and replace either one of these, doesn't matter which. I'll just go with the top. You could easily do the bottom. Okay. Add 30 to both sides. Divide by 4. And we got our solution for x and y. X is -5. Y is -4. And we are done. That is what your test looks like coming up on Thursday. If you have any questions, let me know. We'll have a little bit of review time in class. But you're always welcome to come see me or shoot me an email if you need any help.